Hi guys, and welcome to another video. Today's video lesson we're going to be looking at following grade 11 maths trigonometry, solving trigonometric equations. The question that we're going to be looking at appeared in the November 2019 paper 2. If you look at our work schedule and the series of videos that we've covered under trigonometry in grade 11 thus far will be trigonometric identities, reduction formula, trig equations, and general solutions. Now there's two types of trig equations that we're going to be focusing on in this video and the next one that I'm going to record as well. It says determine the general solution. So we're going to do general solution and we're going to do the specific solution. Now the general solution and specific solution is going to be done in the same way. Just with specific solutions, a domain will be given to us and we're going to write, as it suggests, specific solutions that lie in that domain. So let's get straight into it then. Here's a question here. Question 5.4. Determine the general solution of the square root of 2 times sine x cos x equals to cos x. Now remember that this is an equation, so we need to solve an equation. Now in order for us to solve an equation, we need to make one side equals to 0. Therefore, we're going to get root 2 sine x times cos x, and we're going to move this cos x over to the left hand side, so it's minus cos x equals to 0. All the rules for equations now, remember, exist here, and we can now take out cos x, as you can see, as a common factor. So you can now remove cos x into the square root of 2 times sine x minus 1 equals to 0. Therefore, what are we left with here? We are left with cos x equals to 0, so let's write that down. Cos x equals to 0, or we got square root of 2 times sine x minus 1 equals to 0. Let's solve this one here now. So if you solve here, you get root 2 times sine x, or root 2 sine x equals to 1, and therefore sine of x is equal to 1 over root 2. Do you recognize that 1 over root 2? Yep, that's a special angle. Okay, so when we're finding our reference angle now, you should know that sine inverse of 1 over root 2 should give us 45 degrees. But we'll use our calculator. So our next step is, after solving the equation, is to find our reference angle. So our reference angle here will be cos inverse of 0. Okay, remember now, cos inverse of 0. Let's go put that in the calculator. So we're going to say shift cos 0 equals to 90 degrees. So that's 90 degrees. So that's our first reference angle there. And here, the second reference angle that we're dealing with here is sine inverse of 1 over root 2. And let's put that in the calculator. So we say shift sine, but 1 over root 2, 1 over the square root of 2, right? Let's put that 45 degrees. So actually that's going to be 45 degrees. Now our next step is very important. Now watch very carefully now, because we need to know our cast diagram here, right? Now cast diagram is as follows. Okay, so it's, as you can see here, right? That's your first quadrant, second quadrant, third quadrant, and your fourth quadrant. Now we know that all ratios are positive in the first quadrant, sine is positive in the second quadrant, only tan is positive in the third quadrant, and only cos is positive in the fourth quadrant. We need to know our formulas. Theta, 180 minus theta, 180 plus theta, and here 360 minus theta. Now this is very important. I'll tell you why. See here, you got cos x equals to 0. Now 0 is taken to be positive. So what we need to do now to write the general solution for this question over here now is that you need to see where cos is positive. Cos is positive in the first quadrant and it's positive in the fourth quadrant. So we need to write the solution for the first quadrant and the fourth quadrant. So we can write down first, right? See, first quadrant, your reference angle is 90. So what you're going to write? See there? Right? So the reference angle is 90. So therefore, you have to say x equals to 90 degrees plus k dot 360 degrees. Now let me explain this very quickly. Why do you say k dot 360? Remember, k is any integer value, right? Any integer value, and 360 degrees is a period of cos x. So therefore the graph of cos now repeats itself every 360 degrees. That is the graph of cos of x, right? So therefore you have to say k dot 360, and k is any integer values, right? And then you have to say that k can be any integer value, so k is z. Now you can't simplify that any further. So now we go write the fourth quadrant solution. So the fourth quadrant solution will look like this now. See here, fourth quadrant, you've got 360 minus theta. Theta is your reference angle. So if you go back here, you say your reference angle is 90. So therefore, in this case, you'd say x equals to 360 minus 90 is 270 degrees. So 270 plus k dot 360. K can be any integer value, right? So that's your general solution for, where's it here? Cos x equals to 0. That's your general solution there. Remember, cos is positive in the first and the fourth quadrant. Now for this one, sin x equals to 1 over root 2. Remember now that 1 over root 2 is a positive value once again. So we need to look at where sin is positive. Now sin is positive in the first and the second quadrant, so we need to use the following formulas, right? So remember, your reference angle is 45 degrees. So therefore you'll say here for this question, the first quadrant, your reference angle is 45, so you've got 40, x equals to 45, right? So you're going to say x equals to 45 degrees plus k dot 360. Once again, we'll say k e z. K can be any integer value. Now once again, why do you say k dot 360? For sine graphs. Now once again, remember that the period of y equals to sine x is 360 degrees. Okay, just like the period of y equals to cos x is also 360 degrees. Therefore you say k dot 360. K is z. That means k can be any integer value, because remember now that these graphs are continuous graphs. They exist from minus infinity to infinity. They are continuous. Now the second quadrant, remember, because sine is also positive in the second quadrant, so we're going to write second quadrant and we say x equals to 180 minus theta. Now theta is your reference angle, so 180 minus 45. You use your calculator there. So you can say 180 degrees minus 45, and that's going to equal to 135. So we'll say x equals to 135 degrees plus k dot 360. Once again, you'll say k e z. K can be any integer value. That's your general solution now. Okay, that is your answer. Now let's say, for example, they asked you for the specific solution, right? So for a specific solution, now I'm just giving you the domain here, right? So I'm telling you how you will do specific solution. Let's say they gave you the domain. They said they want a specific solution in this domain here. Let's say from 0 to 360 degrees. So that means now we have to only write the answers in the domain from 0 to 360 degrees. So therefore we'll write the answer like this. Now we'll say x element, right? And we'll write all our solutions inside these two curly brackets here. So now how do you do that? Well, it's very simple really. All you need to do is you need to program this thing in your calculator. So let's start with this one, 90. It's a bit of a tedious process, but we have to do it. 90 plus, see for k now, we're going to put an open and close brackets times 360. Now if you look very carefully, you see if I put minus 1 there, right? Because that's an integer value. I'm going to get a negative value. Minus 360 plus 90 is a minus value. It doesn't fall in this domain, so I'm not even going to waste my time and do that. If I put 0 there, then it's going to be 90 degrees. 90 degrees falls in this domain. So my first answer will be 90 degrees. Okay. If I put 1 over there now, the brackets, it's going to be 90 plus 360. That should be about 450, right? 450 is out of the domain if you look carefully. Right? I gave you a domain 0 to 360. You can only accept answers inside of the domain. Right? So now we've exhausted the first one. So you go to the next one. So you repeat the process. So you're going to go here, 270. 270 plus. See for k now what you're going to do. You're going to put open and close brackets times 360 degrees. Once again, learners, if I put minus 1 there now, right, I'll get minus 360 plus 270, I'll get a minus 1. No use me putting minus 1. So if I put 0 there now, my next integer value, 270. See, 270 lies in this domain. So therefore, I'll write 270 because it lies in the domain. If I put 1 there, right, it's going to be, right, a value greater than 360. So we can't accept that particular value. So we've exhausted all the answers here, right? So now we have to go to the other side now. So if you go to the other side, what you got here? 45 plus k dot 360. So let's write 45 plus, for k you must put open and close brackets, times 360, right? So let's put there plus k times, right? So see, once again here now, if I put minus 1, then I'll get a negative answer there. If I put 0, I'll get 45. 45 is acceptable solution because 45 degrees lies between 0 and 360. If I put 1 there, it's going to be greater than 360. So I'm not going to accept that answer. So I've exhausted all the values there. Let's go to the last one now. So we've got 135. So now you put 135 plus, open and close brackets, plus, plus, open and close brackets, times 360. Once again, guys, look carefully. If I put minus 1 there, I'm going to get negative answer. If I put 0, 135. 135 lies in this domain here. So 135 degrees there, right? So that's an answer. If I put 1 there, it's going to be greater than 360. So I've exhausted all the different solutions. So these are all of my answers that lie within this particular domain. And that's how you do a specific solution. So that's basically, you just take it one step further if it's a specific solution. Once again, learners, if you haven't subscribed, subscribe to my YouTube channel, JL Maths, like my Facebook page, Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on my website, jlmaths.com, and I'll catch you in the next video.